Modulus graphs are confusing when we start them, and when we introduce negatives, they can become even more confusing. Let's start with y equals x and y equals negative x. And we're going to draw graphs, or rather sketch graphs, of each of them, and then we're going to see what happens when we take moduluses of each of them. So y equals x is obviously something like that, if that's y and that's x, and y equals negative x. Let's think, every time I have an x value, I don't take that, I put the negative down there. So it's the same thing reflected in the x-axis. What happens if I take the modulus of each of them? Well, y equals the modulus of x means that I take this first graph, the y equals x graph, and I take the magnitude of each y coordinate. So the magnitude from there upwards is exactly the same. So on the right-hand side of the graph, from the y-axis to the right, it looks exactly the same as that. For negative x, well, whatever my negative x value is, I take the magnitude of it, so I ignore the negativeness of it and simply make it positive. So it looks like that, and that's a graph of y equals the modulus of x. Let's see what happens if I take the modulus of that graph over there, which is y equals the modulus of what I have there, which is modulus of negative x. Well, in that case, I have my x here and y there. I take the value, the x value of each, I negate it, and then I take the magnitude of it. So here's my y equals negative x. What's the magnitude of each of these points? Well, as I go further negative, well, the magnitude of it is getting further positive. So actually it's the same as that. And on the left-hand side for negative x, well, if I negate that, I get a positive, and then I take the magnitude, so it is in fact exactly the same. So those two graphs are precisely the same. But let's see what happens if we put the magnitude and negatives the other way around. Think back to function machines from when you were in Key Stage 3 and in lower school. You'd take function machines and you'd have an input and an output, and you may have more than one stage on the way. Let's see what's happening over here. I'm taking my x value, I'm finding the magnitude of it, and I'm putting out a y value. Over here, I'm taking my x value. The first thing I'm doing is timesing by -1. Then I'm finding its magnitude, and then I'm putting out a y. But if I have a different graph, something that looks like y equals negative of mod x, then in that case, I am taking my x value, I'm finding its modulus, or magnitude, I'm then negating it, timesing by -1, and then putting out a value of y. So in that case, if I start with my y equals x graph that looks like this, there's y equals x. My first job is to take the modulus of it, which looks as what we had earlier, which is x. Y this way looks the same, and this way is the mirror image in the y-axis. So this graph is then y equals mod of x, modulus of x, so that's y equals x. So I take the modulus, then I multiply by -1. But what I have here then is the y value of each of those multiplied by -1. It becomes essentially it is in fact a coefficient of -1 in front of the y. So I take every y value and I make it negative, or make the negative positive. So this, what I have here, is y equals the modulus of negative of x. Modulus, try again, is the negative of the modulus of x. And that's how we calculate with moduluses and negatives, not calculate, sorry, that's how we sketch moduluses and negatives very carefully.